That's a little better. All right. Welcome. Good morning. Hope you enjoyed the party last night. We were trying to get the demo working last night. We had a bunch of VMs to move around and carry equipment over here. So it all worked. This morning, one of them had some problems. We played with it. We rebooted the host. It appears that's fixed the problem. We'll find out in about 45 minutes or so. So welcome to our Lync session today on disaster recovery and high availability. What we'll talk about today is the HA capabilities in Lync 2013, how they're different from Lync 2010 and OCS in the past, and the capabilities around pool failover, or what we also call site resilience or disaster recovery, the capability to have one pool act as a backup pool in your organization and have users fail over from one of those pools to another pool. If all goes well, we'll show you the execution of that in a Lync environment, and we'll find out in about 20 minutes. So, with Lync, we've been developing the capabilities around unified communications for the past decade or so as we went from LCS to OCS to Lync 2010 to Lync 2013. And starting with Lync 2010, we started to provide some capabilities around pool failover. And so in that version, we had some capabilities for voice failover. So our assumption, right, is that voice is the highest priority workload. And so a Lync client running enterprise voice or a Lync phone edition device, for example, can register to a pool. It also can have a backup pool associated with it. And in the case of a pool failure, that client will automatically register to the backup pool. User can place and receive phone calls. Their dial plans, their numbers, their routing, and everything is already replicated throughout the environment. And so we had this failover capacity for voice. One of the issues with that, however, is that we see a lot of customers deploying Lync that are using it for instant messaging and for conferencing as the primary workload and have a subset of users enabled in the organizations for enterprise voice. And so everyone has come to us and said, hey, we like the pool failover capabilities for voice, but we'd like to see that extended to instant messaging and conferencing. Some organizations have actually went and scripted this process. It's actually relatively straightforward. There's some work involved to, on a periodic schedule, export your instant messaging and conferencing settings and capabilities, have that information copied over to another pool. In the case of a failure, you force rehome users to that pool, import their settings, and voila, you've achieved pool failover in Lync 2010. With Lync 2013, we've expanded that to be part of the product itself. We understand that those are critical pieces in most organizations. We wanted to have that automatic versus some sort of manual process that the administrators would do. We had other customers attempt to achieve this by taking the pool and stretching it across two separate locations. Lync 2010, we called that the metropolitan site resilience approach. That required a shared storage environment that was stretched between two locations. There's some latency impact associated with that, which is why we called it the metropolitan approach. It doesn't work when we do that over longer distances where we exceed some of those latency thresholds, for example. And essentially, we want to be able to make this pool failover approach, right, our preferred one. And we'll talk about some of the reasons and the rationale behind that as we walk through. Looking at the roadmap, right, over the past couple of years, you can see that we started out, and we've always had this concept of high availability inside of the pool. We'll walk you through the differences and sort of what happens when you're in a server failure inside of a pool versus a pool failure itself. From an OCS 2007 R2 perspective and prior, we required a hardware load balancer to achieve that. From Lync 2010 and Lync 2013, the clients have a technology called DNS load balancing built in. And if you're not familiar with that capability, essentially every time a client boots up and registers to its pool, it discovers all of the servers in that pool and then randomizes the servers in that pool and connects in that randomized order. And that randomized order is consistent and unique per client, so you can always tell at each individual client level what its preferred sequence number for servers that it would attach to in the pool. And therefore, if its primary server is unavailable, it tries its secondary. Secondary is unavailable, it tries its tertiary, et cetera, throughout all the servers that you've got deployed there. We don't require a DNS load balancer for that capability at all. What we do require a DNS load balancer for is the web services associated with a pool. We have the capability for SIP failure in the client, but from a browser perspective, we don't have that automatic failover because browsers don't have a way of doing this DNS load balancing logic that we built into the client. So from a browser perspective or from the Lync client perspective, when it tries to connect to an HTTPS service, for example, to do an address book query or other functionality there, we require a hardware load balancer to provide that availability. We do see some organizations deploy just standard traditional DNS load balancing, right? The issue there is if you ping the DNS address that's unavailable, sometimes you won't see the failover to the alternate one that's still available in the pool. So recommended is hardware load balancing for the HTTPS services and DNS load balancing for your Lync clients that are deployed. What that simplifies is from a hardware load balancer perspective, you no longer are required to load balance SIP traffic. You're only load balancing HTTPS traffic. That's very straightforward. Most organizations are familiar with that process. We did see issues in R2 and prior as organizations tried to configure load balancers for SIP traffic. That's a little bit more complex and outside of the realm of what a load balancer configuration typically does. From a back-end failure, typically in Lync 2010 and in OCS 2007 R2, we would leverage SQL and shared storage as the way we achieved server-level failover. The servers would write their data to SQL. SQL puts it on shared storage. If one of the front-end servers in the pool goes down, another front-end server can read from that SQL database and shared storage and have all the information available for the user. That would include things like present state, buddy lists, right, scheduled meetings, are all stored back in that SQL database. One of the issues with that is that from a SQL perspective, that requires, first of all, the SQL environment always to be available. And second of all, because we were storing transient data, such as presence information back in SQL, that meant that SQL had to be very performant. So if we had performance issues on the SQL side, that would be reflected from a user level because your client is trying to read or update presence, for example. It's writing it to the Lync front-end server, which is running and has plenty of CPU capacity, but if SQL was the bottleneck, when it would try to commit that right on the back end, we would see sometimes performance issues at the client side. I think this was actually animated and there we go. Forgot to bring it up. The advantage in Lync 2013 is we're trying to move away from this concept of single points of failure in the environment. So not just do we want to provide things like pool level failover, but we also want to make sure that that SQL backend is not that critical path or single point of failure that we have for all of the activities at the client side. So from a SQL perspective, we recommend SQL mirroring. We've actually, at RTM, we had a bit of a confusing support stance here. We supported SQL clustering if you had clustering for your 2010 pool, and if you upgraded to 2013, we could therefore leverage that SQL cluster. If you were deploying a net new Lync 2013 environment, we said we only supported SQL mirroring. That led to some confusion and some feedback, so now we support both mirroring and clustering. We'll talk more about that in the back-end HA portions. But the point being here is that by moving some of the services from SQL off to the front end, such as that transient data, we're able to have a smoother failover experience, and we also don't have that reliance or the criticality on performance on SQL as the back end. From a site resilience or disaster recovery perspective, we have the capability in Lync 2013 now not just to have, like we said, enterprise voice failover from a pool level, but also the concept of instant messaging and conferencing. And if all goes well, you'll be able to see us walk through a demo of that in about 15 or 20 minutes. The goal is to spend most of the time actually walking through there. We'll hope those are okay. As we said, we had an issue with one of the Hyper-V hosts, but it appears it's coming back now. It's almost everything. As we point out at the bottom, it doesn't include some components. So response groups, call park, CAC, and call detail records are not one of the things that fail over in a pool level failover. The rationale behind that is obviously we have the goal to do all functionality when we have a pool level failover, but we also have the ship schedules to be aware of. And so what happens in the development side is we continue developing. At a certain point, we fork or ship the code, the development work continues, and we go on. Another way to say or to look at this is to get all of the UC capabilities, so the functionality that you see at the client side and for example, the capabilities that you saw, if you saw Paul's session Wednesday morning on conferencing and the integration with all the devices, and full availability and site resilience and everything works seamlessly regarding of what fails, we would be calling the product, right, Lync 2015, and you'd still all be running OCS 2007 R2 today, and we'd have to wait that long before it comes through. So as we add capabilities, we ship every couple of years. It's been about 18 months to 2 years on the Lync side. And we are obviously continuing to invest and improve the HADR story on the Lync side. Finally, from a full location failure perspective, we have the same approach for Lync 2013. We would call that a site failover or a pool failover type approach. OCS 2007 R2, we really didn't have a story there. With Lync 2010, we talked about the metropolitan site resiliency. So if you had two close proximity, well-connected sites, we could achieve something. But in 2013, we can do the pool failover regardless of latency in the environment. So in general, we could have pools that are geographically dispersed to thousands of miles, for example, right, and still retain that full pool failover experience from an end user perspective. So now that you know sort of the summary or the high level of what's changed in Lync 2013, the rest of the session is broken out into the front end HA story, the back end HA story, the site or pool failover story, and then some concepts around standard edition versus enterprise edition and what the HA and DR plans are around both of those. From a front end perspective, we call that the autopilot approach, right? So if you're familiar with the movie Airplane, that they had the old autopilot gentleman. But the front end story is very straightforward. This requires enterprise edition. However, once you have an enterprise edition pool deployed, if you lose a front end server in the environment, your client will automatically connect to a different one. I'm not sure why those came out that way, but seamless failover, right? There's no data loss from a pool perspective. Your client automatically reconnects. No hardware load balancers are required from a SIP perspective. Clients will just re-register to another front-end server in the pool. Administratively, you'll get an alert that one of the servers in the pool has failed. You'll take some steps to recover that server. When it comes back up, those users are back online and will connect automatically. We don't have an issue, right, or some concerns around what that pool failover experience, server failover experience would look like. The method that we use to achieve this is something called Windows Fabric. So Windows Fabric is new for Lync 2013. It's part of Windows Server itself. And it's a method that we can use to replicate information between the front-end servers in the pool and ensure that they're always up to date and aware of the capabilities on the other side. The way the Fabric works is we divide the users into what we call user groups, and we'll spread those user groups and their transient data across 3 servers inside of a pool. So there's user group 1, user group 2, user group 3, etc. Your users are automatically carved up into these user groups, and we'll replicate all of that the transient user information among the front-end servers that are a member of that specific user group. What this means is that we can fail you over to any one of those 3 front-end servers without having to go back to SQL to query that transient information. So we've offloaded some of that back-end performance requirement from SQL, and we've improved the failover time by ensuring that if you have a pool of 6 front-end servers, right, any 3 of those have a full up-to-date copy of your transient information at any given point in time. This is automatic. As you add servers to the pool, we continue to expand and deploy the Fabric and replicate the information automatically for you. So there's no administrator thinking or carving or decisions required to achieve that level. The corollary to this is that means that our recommendation for the minimum number of servers in a front-end pool is 3. Windows Fabric also has what we call the quorum model, which means that we want to have an odd number of nodes available, a number of nodes available in that quorum to achieve quorum for that. So if we look a little bit deeper here in the Fabric portion, we see that we really have 2 types of data that are stored in your Lync pool. There's transient data. That's going to be the things such as your presence information, right? So did it change from free to in a meeting or in a call? That's something that's dynamic at the client side. If I were to go to another server that doesn't have that information, I can always recreate that client side. It's not something that has to be pulled back from SQL, for example, because I want it to withstand an all-server outage. So if all the servers in the pool were to go down at the same time, my transient data would be lost. That would be the active conference roster, which MCUs are being leveraged, right, and things like my dynamic presence information. When I reattach, those are easily restored, and so I don't need to store that in SQL. There's other data, however, such as our persistent data, right? This would be things like our scheduled conferences, our contact lists. When I make a change to one of those, I want that change to be persistent even if I had all servers in the pool outage. I would expect that data to be restored, right, or to be available the next time I reconnect. Persistent data is stored on the front ends, but then submitted in a lazy write operation back to SQL. So again, we don't have a hard requirement. We can withstand a temporary SQL unavailability or performance issue, right? We'll just queue it up on the front ends and write that data back later. But we do want to make sure that that persistent data is stored in SQL. That ensures that if we lose all three of those front ends in the user group, we will still continue to have that persistent data stored back in SQL. So you can see us offloading some of that performance requirement from SQL. First of all, the transient data, we don't have to store there at all. And second of all, the persistent data, we'll cache that on the front ends and lazily write that back to SQL so we don't have that high-end performance requirement on the SQL side. You may have noticed if you looked at the hardware requirements for Lync 2013 that we are not as stringent on the SQL side. However, we have upped the storage requirements on the front end side as a result. So obviously, capturing both transient and persistent data and replicating it via Windows Fabric increases our disk I/O on the front-end servers, and so the front-end server disk requirements has went up as a result of that. We want to make sure that we've got a well-performing set of disks on our front-end storage. We also use a concept called blob storage and deep chunking, essentially a way to optimize the data as we're writing it to SQL, so it's a smoother write operation on the back end, again trying to reduce our SQL performance requirements. We mentioned the concept of quorum. So from a Windows Fabric perspective, we will have to have an odd number of nodes in the pool and a majority of those running in order for us to maintain and achieve quorum. To get automatic types of failover, if we have, and let's take the simplest example, 2 servers in a pool that are running, and server 1 cannot talk to server 2. We now have a quandary. Is there a network connectivity problem between server 1 and server 2, meaning that they're actually both up and running and servicing clients? Or is server 2 down, right? So if server 1 cannot reach out to server 2, it doesn't understand what the impact is there. Do I continue to service clients? Or is server 2 also servicing clients, and now we have what we refer to as split brain, both of us servicing the same clients, trying to do the same things. With a quorum model, we say that we need to have a majority available. So in the 2-server model, let's say we have 2 front-end servers in the pool. The SQL or the back-end server then becomes the third member or the odd member, and so therefore we have 3. And as long as 2 of the nodes can communicate, they know that they're the surviving nodes. If there's only 1 node and it cannot talk to the other 2, it will automatically go offline, even if it has no technical problems. And so in a quorum, we always need that majority number. This means that whenever we have an even number of nodes in the pool, we'll leverage SQL to be the next one, which brings us to an odd number. If we have an odd number of nodes in the pool, we do not need SQL because we already have an odd number, right? So if we have 5 or 6 nodes in the pool, we need at least 3 nodes to be available, which brings us 3 out of 5 would bring us to a majority, which means that we'll continue to run. We talked about this concept of SQL. Like we said, anytime you have an even number, we'll add SQL. This brings us to an odd number, and so therefore we know how many nodes have to be available. It's relatively straightforward for us to find out whether or not we're leveraging SQL and or which nodes are part of the quorum. We can easily go up to the program data, Windows Fabric settings.xml, and there's a list, right? In our 2-server pool, we can see 2 front-end servers with SQL as the third node. In a 3-server pool, we just have the 3 front-end servers. In a 4-server pool, again, we went back and added SQL. This does bring up an interesting concept around SQL mirroring. In a SQL mirror, we only leverage the primary SQL node as the odd member of the quorum. So if we have a SQL mirror and there's a primary and a secondary, and our mirror has failed over to the secondary because the primary is down for maintenance, that odd number is down. So if we had 2 servers in the pool, for example, and we then bring one of the front-end servers down for maintenance, that leaves only 1 surviving quorum member, and it will automatically go offline. So whenever we have a SQL mirror on the back end, we do have to be aware that it's only the primary node that is the one affecting quorum. It's not the auxiliary SQL node, which as a result means that we have to take that into account when considering maintenance or patching or rebooting any of our front-end servers in the pool itself. This also brings up some caveats right on the 2-node front-end pools. When we have 2, That means our quorum is 2 because there's 2 servers plus the SQL server makes 3. We need a majority, which means that we have to be careful about stopping services and rebooting servers because it's very easy to get us to a lack of quorum, right? If we patch SQL at the same time we patch one of the front ends, that surviving front end is going to go offline and stop servicing users because it's only one of 3 and has lost quorum. Last server to update the quorum has to be restarted first, otherwise you'll get this situation or scenario where the other front-end service continues to hang. You can reverse that just by shutting them both down and reversing the startup sequence on that portion. And as we called out, right, in a SQL mirror, only the primary SQL node is the one that's participating in the quorum. The passive or the secondary SQL node is not going to achieve or not going to provide that capability for us. So, questions on the front-end portion? It's automatic, assuming that you're familiar with quorum, right, and making sure you always have that minimum number of nodes participating to ensure your availability perspective. SQL also, we've changed our approach for availability. We had this analogy, right, so if clustering is wheels and provides us some capability and some failover logic, then what is mirroring? Mirroring would be the future. So mirroring essentially is our method of saying we don't want a single point of failure. If we go back in time to the early days of computing in the 60s, 70s, and 80s, the way people achieved availability was providing redundancy inside of the chassis or the mainframe, right? So we added other additional processors and logic on the mainframe side. On the storage side, we added additional storage processors. We added additional drives. We used technology such as RAID, for example, and we had a large, complex storage environment. We then used a complex interconnect between our mainframe device and our storage with multiple paths and multi-pathing capabilities to ensure that if one of the paths to the storage failed, we would maintain that. As we started to develop Windows applications in the early 90s and mid-90s, we wanted to start to add availability to these Windows applications and Windows servers. And of course, the people we hired to do high availability planning all came from the world of the way you achieve that is a shared storage model, right? The typical clustering environment, we will use multi-pathing software, multiple paths, et cetera, et cetera, et cetera. By the early 2000s, we realized that this is a both complex and a difficult endeavor to pull off and maintain high levels of availability. From a shared storage perspective, we would regularly see these shared storage environments fail because of the complexity involved. And we can kind of walk through a quick count, right? We have Windows as the operating system. We have a hardware driver for the HBA or the storage controller in the device. We have a vendor that provides that third-party HBA, for example. We've got a path from the HBA to our switch fabric. That's another vendor typically. We've got the switch fabric and another path going down to the shared storage processors, yet another vendor most likely. That storage processor then has some paths to disks and storage itself. So we have in this topology probably 3 to 5 vendors involved. And to upgrade the BIOS or the firmware on one of those components, it's typically certified as a unit. And so therefore we have to do any upgrades in conjunction with the other vendors, meaning we can get into this cart before the horse where, well, to fix one of our bugs, we have to upgrade the firmware on the storage processor, but that's not yet certified with our current version on the switch or the current version on the HBAs. And we'd get into these areas or periods of time, right, where we see technical problems, but we have a challenge addressing it even though we know the path forward. Starting in that same time frame, the late 90s to early 2000s, people started to realize a different way of providing availability, and we call this sort of the brick model. There's a few white papers published on the internet talking about this concept of you use a standard 2U server, or 1 or 2U server, right, a 2-socket server, attach some local storage to that, and just use software to replicate your configuration information and your data from that server to another server in the organization. At this point, the only shared component is the network. If you lose one of those units, whether it's the CPU, right, the host, the storage, the other component automatically starts servicing the clients. We'll leverage some type of quorum model to have it automatically figure that out, and it will activate and begin servicing. It's much simpler, it's easier to deploy, and it's the method that leads to the highest levels of availability. From a Microsoft perspective, you're probably most familiar with this in Active Directory. With Active Directory, we use software to replicate your user information around. We can take out any domain controller at any given point in time. We might have a performance issue at that location where the DC has failed. However, you still will see users logging on and accessing the service. Same concept from the Exchange side. You see us replicating Exchange to more than one mailbox server, right, and or more than one location. We expect any of those to fail at any given point in time, but from an end user perspective, their Outlook client, ActiveSync, et cetera, continues to get the mail. You're seeing with mirroring, right, this coming to the SQL side. With mirroring, we have two SQL servers. There's a principal instance and there's a mirror instance. Lync will point to the SQL mirror. If that principal instance goes offline for any given reason, could be maintenance, could be an unexpected outage, we will fail over to the mirror. Lync will continue working with the mirror on that side. And from a user perspective, right, we don't have an outage. There's no realization that that has occurred. We'll get a notification, and we will take some action to recover that principal instance. But while we're recovering, the service has continued to operate. So from a Microsoft perspective, we like this concept of replicating the data, having more than one instance of it, and therefore, in a data loss or server failure type scenario, the service stays functional, the end users are functional, and we don't have to take any client actions or administrative actions to go through that recovery or go through that activation process. With SQL Mirror, the witness is optional. That could be just any other server. It could even be a SQL Express server in your organization, for example, and provides you automatic failover. If you don't have the witness, you'd have to manually activate your mirror instance. Same concept of quorum applies there. We need an odd number. 2 is not an odd number, right? So by adding the mirror, we have the capability to do failover. The failover impact from a SQL side are when we went through our design and planning for Lync 2013, we had an RPO of 5 minutes. It's typically very rapid for SQL to do its failover. The data replication in the SQL mirror is synchronous, meaning just 30 seconds. Is synchronous, meaning that when we write the data back to the primary, the data is written both at the primary side and the secondary side before we report the write back to the host, which means that even if we lose the primary, the secondary always has every bit of information that the Lync front ends tried to commit to SQL. Question? Probably always on? Or? Yes, yes. So question is version of SQL supported on. We are supported on SQL 2008, 2008 R2, and SQL 2012. Mirroring has changed in SQL from 2008 to 2012. SQL has also introduced a capability called Always On. We have not yet tested Lync with Always On. Always On is SQL mirroring, but instead of using the witness as a method of arbitration to determine how should quorum operate, uses shared storage as its quorum that they both write to get the update. So we haven't yet tested with Always On. I don't have anything to announce as to whether or not that will be supported at some point in the future or not. The request has come up, but it's newer, so we haven't had the chance to digest it and incorporate it on the Lync side yet. So our recommendation from a SQL side is mirroring. If you need to provide high availability on the SQL side or the back end, you can, however, still deploy SQL clustering. Sometimes that decision is not a technical decision. There's a SQL organization in the group, right, and they've got a well-run, well-managed SQL environment on a cluster. You're more than welcome to use that SQL instance on that for your Lync 2013 environment. If you have a witness configured with your SQL mirror, there is no user notification or user perception or awareness during that failover process. The pool will automatically start using the auxiliary or the second node in the mirror. If you do not have a witness, you'll go into what we call resilience mode. We'll talk a little more about that because there's quite a few things that can trigger resilience mode in the Lync client, and you'll have to take some action to fail over to the secondary or auxiliary node in the SQL mirror. While you're creating a SQL mirror, you'll be prompted to create a file share. And just as a heads up, creating a SQL mirror in Lync is very straightforward, even if you're not a SQL expert or don't have an awareness of how to configure SQL. If you have 2 SQL instances available, You tell the topology builder in Lync, this is my primary, this is my secondary, this is a file share which is temporarily used to set up the mirror, and Lync topology builder will configure the SQL mirror for you. So if you have two SQL instances, we recommend giving them the same instance name. It makes the configuration and troubleshooting a little easier. Doesn't have to be. Topology builder will go out and generate it. During that generation or creation of the mirror process, we need a temporary file share. So we create a file share somewhere in the organization. Don't use your Lync file share that you're using for conferencing and for meetings. On that file share, the primary SQL server needs read-write. The mirror needs read-only. During creation of that, right, that it's provisioned and created automatically. You don't need, or we don't recommend, obviously, DFS for that because the files that we put on that share during creation of the mirror have a .bak extension, and those are excluded from replication. So use a standard file share, and you'll avoid any DFS issues associated with that. Once the mirror has been created, we don't need that file share anymore. You could decommission it, not required going forward. A SQL mirror also has some TCP ports associated with it. By default, that's TCP 5022 and 7022 for the relationship with the mirror for active primary auxiliary communications and for communications with the witness. We show in the in SQL you can run a run a script, right, to show you what those are. We gave you the reference information here on the slides. Questions on SQL? Yes. Pardon? Oh, the communication between the witness and the primary and auxiliary is, I'll have to double check, but my understanding, I don't believe it's encrypted at this point. I think it's just a keep alive that we're sending out there. And so the question is, how do we communicate between primary, auxiliary, and the witness? Primary is writing a note to the witness, I'm available, I'm alive, I'm available, I'm alive. The auxiliary is checking. When it sees that the primary has stopped, it knows that it assumes that at that point, if I cannot reach the primary on the network and the primary has not updated the witness, primary is probably offline, I can go and activate, right? So very straightforward arbitration process to determine quorum. Pools. So the second piece, right, or the third piece, I guess, we talked about front ends and how those can fail over. We have the back end capability. Let's talk about the pools itself. Oops, let's go forward. And what happens in our pool example, right? So we want our pools to be kind of clean and pristine. We don't want them to have problems. If they do have problems, we don't want to have to go through some administrator action to do recovery while everyone's down. We'd like them to be able to resume service automatically as quickly as possible and then go and fix the problem on our own time. Pool backup is a pairing relationship. So we have pool 1, pool 2. Pool 2 backs up 1, pool 1 backs up 2. We configure the pairing relationship in Topology Builder. We'll show you that pretty quickly in the demo portion here. One of the aspects to think about or to plan around when you're talking about pool failover is the concept of the CMS. The CMS is the central management store in a Lync environment. It's critical for all Lync servers to run and operate. Every Lync server in your org has a read-only copy of the CMS installed, and one of the servers in your organization is the read-write copy. So in a pool failover experience, right, we can fail over, but if the primary CMS was on the pool that failed, we're unable to make topology changes or configuration changes until we recover or restore that read-write CMS capability. It's straightforward to do. We'll show you this in the demo itself. Invoke CS Management Server Failover. It's invisible from an end user perspective, and we can place that CMS then on another server if we're going through a planned failover event from our poolside experience. So I'm going to keep my fingers crossed since until 9:05 we didn't have connectivity from the there's two Hyper-V hosts here. So one of them had issues this morning when we came in, and we rebooted and it fixed it. But you never really know, right? Let's find out. So if we go to my second host, this is the one that has clients. We are in good shape. So let me do a quick check prior. This other host is the one that rebooted. It has 4 guests on it. those 4 guests are a DC. I have a single DC. I have a pool that has 2 front-end servers, so front-end 1 and front-end 2, and I have a SQL server servicing that pool, SQL 1. All 4 of these guests should be running. Let me just connect and see. Yep, and they all came back up because we had to restart. I know FE1 is. And FE2. And SQL. All right, let's go back then to our other Hyper-V host, where we have, very simple, another pool, a second pool, pool 2, front-end 3, front-end 4, and SQL 2, as well as 2 client machines. 1 client is signed into a user object on pool 1, 1 client is signed into a user object over on pool 2. So if I take a look at client 1, it should be signed in. Yep, I can see Eric is there, Eric's available. If I go over to client 2, I can see Stan, Stan is there, Stan is available. If I take a look at Eric, I can check in his Lync client, his configuration information. Here I can see that his MRAS is an edge server on pool 1. If I scroll down, his connected Lync server is FE2, so Eric is homed on pool 1. And if I look at that configuration information for Stan, Stan is, and I'll have to maximize to get down there. Stan is configured or connected to a server on pool 2. And so therefore, I've got a user on each side of the pool relationship. If I come back to one of my servers here with PowerShell up and running, oops, that's not the one. We can do some checks. The first one, we can also see command line side get user pool, CS user pool info for Eric at Mac. And we can see that he's associated, his primary pool is pool 1, his backup pool is pool 2. We can also see for the preferred order, remember we said each client attached to the pool will query all the servers in the pool and then determine a preferred sequence number. So Eric is FE2, then FE1. If he were to fail over, he'd be FE4 and then FE3. We can also check our pool backup one, so get CS pool backup relationship. And I think I provide the pool1.un.mac. And target pool is pool 2. We can also see this in Topology Builder. It's very straightforward to see our pool relationships. Let me maximize again. Bring up Lync Topology Builder. And we'll show you our topology in the Lync environment. There are some other servers in this topology, some edge servers and some persistent chat servers. Those are not up and running just to save some memory, but you will see those and the relationships all defined here. We'll pull down the topology. We're going to pull the topology from the read-write central management store. While Topology Builder is running, we can take a look at our Git CS management store replication status, and it's the central management store status. We can see that our active master FQDN is fe1.un.mac, so we see that our CMS is being hosted on fe1 inside of pool 1. So let's go back to our topology builder. It'll ask us to save a file. Let's give it a name. And we'll see our topology. Inside of our environment, we can see that we have 2 locations, 2 data centers, right? And in these data centers, no Lync 2010 pools, as I expand out. But if we look at Lync 2013, we can see that we have a pool 1 and a pool 2. And if I look at properties of pool 1, I can see that I have a SQL mirror associated with that. I don't have the SQL auxiliary mirror up and running. But I can also see that I've got, for resilience, pool 2 associated as a backup pool, And if I go to pool 2, I can see the same information, right? In this case, the associated backup pool is pool 1. So I pair the pools. Now pool 1 and pool 2 are backing each other up, and I can try to do a failover for that environment. However, since I'm going to fail over pool 1, and I checked and saw that my central management store is running on pool 1, right? One of the first things I want to do is fail over my CMS to a server on pool 2 so that I don't have an issue making changes. This is a planned maintenance event, right? Not an unplanned one. So we'll do an invoke CS management server failover, and our backup server FQDN is SQL 2 UN.Mac, and backup SQL instance name is Lync, and there's a dash force, which we'll say is false. Force is my primary pool went down, the primary CMS is down, let me seize the role, right? So if you're used to Active Directory, sometimes it's unrecoverable, we'll seize it. If it's a planned move event, we don't need to force it. We can just go through and say yes there, and it will move over. While that's moving, we can see, let me go back to my client. And my client, right, has stayed signed in the entire time. We don't have an outage event when we move the CMS. One of the other aspects to consider in a pool failover is my edge environment. In my edge environment, if I go take a look in Topology Builder, I will see, I wish I could keep that up there. I want to show the client at the same time. I don't quite have the resolution to do it. Anyway, if I take a look at my edge pool, I can see what my next hop is. In this case, it's pool 2, right? So I'm already covered from a edge failover perspective. If my edge server environment was set to go to pool 1, in that case, when I failed over, edge's next hop would be unavailable and external access would have a problem. So I'd like to see the edge failover portion first before I invoke the pool failover. That has been covered. Let's do a git cs registrar configuration. We can see that pool 1 is active and is registering clients. We can also see in this point what the endpoint expiration, right, or the time period is for replication inside of that pool and for our backup environment. Let's, before we start our pool, however, or our pool failover, what I want to do is start a user conference so we can see what happens to a user who's in a conference while this pool failover takes place. Stay there. So Eric is going to start a conference. We'll just go meet now. And we'll use Lync audio to join the conference. And let's go ahead and invite to our conference Mr. Stan. He's been inactive. Let's go over to Stan's computer and accept. So now my users are in a conference. Conference is being hosted on pool 1 because that's Eric's primary pool. Conference is always going to be initiated from the pool of the person who initiates the conference. Maybe let's start some activity. We'll start a little whiteboard activity here so we can have some content in the conference. Let's draw some red lines. We'll put some text in there. This is Eric in the conference. All right, users are operational, users are running. We have users from pool 1 hosting the conference, right? We've got a user from pool 2 in the conference itself. Now let's try our invoke CS pool failover with our pool FQDN of pool1.un.mac. Everything else we showed you to this point is kind of checking status, right? We want to see where the CMS is located. We want to see the edge next hop. To do a administrator-defined failover or a clean failover process, we run invoke CS pool failover. And it will take anywhere from 5 to about 15 minutes for this to go through and execute. So let's hit yes. While it does this, what it's going to do is complete replication of the last bits of information, right, from pool 1 over to pool 2. Rehome temporarily the users that are on pool 1 onto pool 2. So we'll see, in this case, Mr. Eric is going to go offline, or not offline, but into resilience mode as the conference and the registrar endpoints that he's working with in pool 1 go offline. He will connect automatically to pool 2, but in resilience mode. And then as the failover process brings Eric's information over to pool 2, Eric's client will automatically reconnect and have full functionality again. So in this mode, right, we've lost pool 1. My client is automatically reconnected to pool 2. I don't have full functionality, such as my contact list, right, and my scheduled meetings, for example. But what I do have is the ability to place and receive voice calls. And we've got a slide coming up that shows what's capable in resilience mode. So we get I save this, right, the first time pop up, we get hey, we got a little network or server issue, user's notified, user loses their contact list, and they get a little message, limited functionality due to an outage. I can place and receive telephone calls, that's about it. If I know someone's SIP address, I can type it in, like if I knew Stan, right, I think Stan is Stan at un.mac. I can see Stan, right, I could actually place a call to Stan, for example. And in about another 5 or 10 minutes, we'll see that contact list get restored and resilience mode go back to normal operation. While that's running, we'll go back and go through a couple of other slides because it does take a bit of time. And continue the presentation. So, CMS failover, pool pairing. Pools can be paired. It's a one-to-one relationship between pools. This gives us no single point of failure, right? We lose a pool, users will fail over to the other pool, will resume their instant messaging, their conferencing. We've already got voice resilience baked into that from Lync 2010. The replication portion is automatic. We have this process called the Lync backup service. It exports the information from pool 1 to a file, copies it to the servers that are hosting pool 2, and has that data ready for import capability. Voice is automatic, as we called out. Instant messaging and conferencing is waiting for that pool failover experience to take effect. Resilience mode. So we talked about this concept of what is resilience mode. You saw the Lync client pop up a little warning, the limited connectivity aspect. During that, essentially, all you can do is place and receive telephone calls. You have limited functionality in the Lync client for that. Slide is up there for reference. I know we're pushing time, so I won't go through all the items around that. Backup service, as we said, is the method that the data goes from pool 1 to pool 2 and inverse, so pool 2 to pool 1. We're replicating data both ways. We export the data, put it in a zip file, copy it to the other pool, use a little cookie as a watermark so we know what is the most recent or the most up-to-date information on the other side. There's a file share that we leverage that pool export data on. That's where we store that zip file. The other server will read that in when we need to do the bring it back. Let's take a quick look to see how we are on our failover experience. We are still running. I can see that we've got a bit of activity there. Let's cover a couple more. Best practices. We only tested pairing Enterprise Edition pools to Enterprise Edition pools and standard to standard. You can try pairing other way around. We don't know what the results will be in that case. It may work, it may not. It may work now, but it may break in a cumulative update, right, or a patch from our side. So on our test matrix, we're only testing equivalent to equivalence on that. We recommend also physical to physical, virtual to virtual. Same concept, right? That's what we've been testing at. But there's some decision points. The big one is, how do you size your pools, right? If I size each pool for 50% of the load, that means that in a failover, I'll have normal operations with a normal user experience. If I size the pools to just handle the users at each location, and then I do a failover, we'll have some performance issues, right? If I put 200% of the users on, or sorry, 100% of the users on a pool size for half, it's not going to be as rapid. We might have slower conferences and or delays in registration or sign-in, for example. The last comment, right, if we do Enterprise Edition, we can also do HA on the back-end servers. So in Enterprise Edition pool, we'll have our front-end servers with SQL mirrors. With Standard Edition pools, we're limited because an SE pool doesn't have a SQL backend. It uses SQL Express. So our only option for Standard Edition pools is that local copy of SQL Express. This gives us what works in a pool failover experience, right? So from a Lync functionality perspective, when we're in site resilience mode, after the pool is, so the backup pool has been activated, we have everything except for CDR, response groups, call park, and call admission control. So it's not 100% of the way yet. We're continuing to work on that on the Lync side, right? But the majority of what users will use from a functionality perspective will be available when they fail over. The correlation between pools is 1-to-1. We often get the question, can I have pool A, pool B backs up A, C backs up B, and then A backs up C? We cannot do that. You'd have to do that via your own process, right? So run the set of commandlets that we use for pool failover to export the data, copy it to pool B, have it ready there, have your own script through the import process. If you use our pool failover logic and our pool failover commandlets, it's a pairing relationship only. The other big caveat is if you have survivable branch appliances, those are only going to register back to one backup pool. So if I have an SBA and I have a paired pool scenario at my core or central locations, the SBA only comes back to one pool. If I have a pool failover experience, the SBA doesn't understand that and fail over to the backup pool, right, in that type of scenario. So we do not have the DR capabilities right now for the branch office side to have SBA plus both pools. It's just SBA plus one of the pools in the environment. Again, another work stream item for us. Let's take a look at our user experience. And we are, okay, so the failover has completed, right? We can now see that Eric's client is no longer in resilience mode. He has converted from resilience mode to normal operations. However, if I go to Eric's configuration, and so we see presenters enter the meeting. I can rejoin the meeting. Let's rejoin that Lync call. And I can go back to Stan and do the same approach. I can rejoin. There was an error. There definitely was an error. The server hosting the meeting, right, essentially went down. I can accept the content. I could unmute if I needed to. Hey, look, so Stan has rejoined. We can see there's our meeting content that was in the meeting prior to the failure. And now I'm on client one. Yep, Eric. When Eric accepts the meeting content, Eric is able to rejoin, re-participate in the meeting. There's my meeting content over on the second pool. So a meeting was originally hosted on the second. However, we replicated all that information over. If I check the config information, I can also see that Eric is now signing into FE4. So Eric is now housed on pool 2 until we go through and do the invoke CS pool fail back, which would move all the users that should be on pool 1 back to pool 1. So we were lucky, I guess, a successful one after a server reboot there just before the session. I was a little worried since I spent a few hours getting everything working last night that I didn't have it ready to go. But fortunately, our demo was successful. Pool failed over. User experience was stayed signed in, right? Was in resilience mode while his information wasn't there. Went back to normal operation once his information was imported, and were able to rejoin any active meetings that were in process. In this scenario, if Stan had hosted the meeting would have been held on pool 2, and the meeting never would have went down, right? So the meeting failure experience is going to depend on which pool the meeting is active or hosted in. Let's go back. From current slide. Final, just a couple more minutes and we'll wrap it up. Standard edition, we have a lot of questions. With this pool failover experience, when do you start using standard edition instead of enterprise edition, right? So this is a very active discussion thread both inside and outside of Microsoft. Enterprise pools take a lot of servers. You heard our recommendation. We can have one enterprise edition server in a pool, right? We can have two, but we're missing some of the capabilities there around the user groups, and we have the quorum discussion to think about. So in reality, our recommendation minimum is 3. If we do a SQL mirror on the back, that's 5. With a witness, that's 6. So 2 pools to get resilience, that's 12 before we start counting edge servers and other components in the organization. So 2 edge servers at each side. We went from 12 to 16. We're at quite a minimum footprint for Lync Server Enterprise Edition. Same concept for Standard Edition, right? We're at 2. We have 2 servers, or 4 if we count the 2 edge servers, 1 at each location. There's some pluses: no hardware load balancer, no backend SQL, no DFS file share. Failure domain is simple. It's a single server. I know exactly who's impacted when there's a server outage, and they'll have to go through the pool failover experience for it. We have fewer servers required, right? And because of some of the improvements we talked about in the voice session, we even have the voice capabilities or voice enhancements around selective trunks and mediation servers. Doing the math, it's fewer servers in the organization, up to 40,000, right? So until we get above 40,000, does the standard edition model lead us to more servers in the enterprise edition model. So as a result, we see a lot of activity or discussion around, well, let's just do 2 standard edition servers, pair them, have the users go through the pool failover experience I just showed you, and keep the environment much simpler with fewer servers in there. Some design guidance: use SRV records for registration. We will need a external FQDN DNS entry because each standard edition server is a pool. Each pool has an internal and external FQDN. Using a wildcard certificate means if you were to deploy 10 of these, right, I don't need 10 names on that certificate. There are some caveats, right? Edge today only has a single next hop, meaning that in the pool failover, I do have to change that next hop for Edge. There is a manual switchover and single point of failure on response groups. Remember, that wasn't one of the things that we go through in pool failover. We say more complex, potentially more complex to manage, right? Standard edition, we have a set of management tasks. We're having to do Edge next hop and pool failover activities. Enterprise edition has a different set of administrative tasks. Now we have SQL backends, witnesses, and quorums to go through. PSTN conference DIDs are associated with a pool. So again, single pool, single point of failure because of standard edition. Metropolitan data centers, they're not supported in Lync 2013, primarily because it's a single pool, single point of failure. When you have a single point of failure, bad things can happen. Don't stretch your Lync 2013 pool. Thank you. I know it's morning after the party, so appreciate you all coming out early this morning. Thanks for bearing with us as the AV guys got the machines restarted for us. We're happy the demo worked for you. Go deploy Lync 2013. Thank you.